6EQUJ5.
August 15th, 1977, Delaware, Ohio. Just imagine a quiet summer night deep in the American heartland. Beneath, a blanket of stars, there's this massive radio telescope just patiently scanning the cosmic background. And then suddenly, out of all that static, out of the vast, silent void, there's a sound, well, a signal, a whisper from the stars. A precise, powerful burst that hinted, just for a fleeting 72 seconds, that maybe, just maybe, we'd heard from another world. Tonight we're embarking on a deep dive into one of the most, well, enigmatic and celebrated moments in the whole search for extraterrestrial intelligence, the legendary WOW.
Signal.
It really is a cosmic cold case, hasn't it? Fascinated scientists and, frankly, dreamers like us for nearly half a century now.
It really has. And what's truly fascinating, I think, is how a single fleeting blip on a piece of paper, right, a paper printout, detected way back before digital data was, everywhere. How that one thing has fueled decades of serious scientific inquiry and intense speculation and, well, just an enduring sense of wonder.
Yeah, wonder is the right word.
So tonight, we're going to explore exactly why this particular signal stands so completely alone, why it grabbed researchers back then, and why it still echoes, in our collective imagination, even after almost 50 years of, well, frustrating silence.
Okay, so our mission for this deep dive, let's try to fully understand the intricate details. What was the WOW signal? How exactly was it detected? Why were its characteristics so incredibly unique and, frankly, intriguing? And maybe the biggest question, what does this single, unrepeatable event tell us about the vast, silent cosmos we're constantly listening to? So get ready for some surprising facts, some deep scientific dives, and yeah, a journey into the tantalizing great unknown. So let's set the stage then. Our cosmic story really begins with SETI, the search for extraterrestrial intelligence. Now, for those of us who follow SETI, the core mission seems pretty clear. But maybe for anyone just joining us on this deep dive, let's just quickly underscore why radio waves are, our main tool in this huge cosmic search. What are we actually listening for out there? And, well, why even bother listening at all?
That's a great starting point. It really is. Because understanding the why behind SETI is key to appreciating the WOW signal. The core purpose is pretty straightforward. Find any signs, any shred of evidence of intelligent life beyond Earth. It's driven by that ancient question, isn't it? Are we alone? The universe is just unimaginably vast. I mean, the challenge of finding that needle in the cosmic haystack, it's immense.
Absolutely immense.
But the fundamental assumption driving SETI for a long time now has been that if advanced civilizations exist, and if they want to communicate across interstellar distances, or maybe even if they're just broadcasting for their own purposes, the most logical, the most energy-efficient way to do that would probably be through radio waves.
Okay, so efficiency is key.
Right. And here's the crucial scientific bit. Natural cosmic sources, think stars, quasars, galaxies, black holes, all that stuff, they emit radio waves, sure.
Yeah.
But their emissions are almost always broadband. That means the energy is spread out across a really wide spectrum of frequencies. Imagine it like a noisy waterfall or maybe a full orchestra playing every instrument at once. It's diffuse, scattered.
A lot of background noise.
Exactly. But an artificial source, something engineered by intelligence, could focus its energy into a very tight, very specific narrowband frequency. So instead of that noisy waterfall, you hear like a single pure, perfectly tuned flute note.
Right.
That narrowband signature is incredibly difficult, maybe even impossible, for natural astrophysical things to produce. It's like finding a highly organized, coherent pattern in what's otherwise just cosmic chaos. So that's why SETI specifically tunes into these narrow bands, because they're a really strong candidate for something artificial, not natural.
Okay, that makes perfect sense. Searching for that cosmic sleep note. I like that analogy. And that search brings us to a specific frequency. Now, this is where I find it gets really interesting. Of all the possible radio frequencies out there, and the radio dial is unfathomably huge, right? Why did astronomers decades ago pick this one particular frequency to listen to? Why zero in on that spot?
Ah, that choice. It really gets to the heart of SETI's, well, ingenious strategy. It's a brilliant example of scientists trying to think like potential alien communicators might think. The frequency they chose is 420.4058 megahertz. It's universally known as the hydrogen line or sometimes the 21-centimeter line.
Hydrogen line, okay.
And its significance is just profound. Hydrogen is, quite simply, the most abundant element in the entire universe. It makes up something like 75% of all normal matter. It's everywhere.
The basic building block.
Pretty much. And at this precise frequency, 1,420.4058 megahertz, neutral hydrogen atoms floating around in space. They naturally emit faint radio waves. It
Okay.
happens when their electron does this little quantum flip, changes its spin state. It's a fundamental physical constant, a signature of the universe's most common stuff.
Wow.
So the hypothesis goes, right, that if an intelligent civilization out there wanted to make contact, if they wanted to broadcast a message that any other intelligent civilization, no matter their biology or culture, could easily find and understand, they'd probably choose a frequency that's universally known, something fundamental to the physics of the
It's
cosmos.
like a universal meeting point on the dial.
Exactly. It's like agreeing on a universal greeting channel, a specific spot on the cosmic radio dial that any technologically advanced species anywhere would instinctively know to check. It really is seen as a universal hailing frequency, a common denominator for intelligence across the vastness of space.
That's brilliant, actually. So the instrument patiently listening for this cosmic hailing frequency back in '77 was the Big Ear radio telescope. It's got such a wonderfully evocative name, almost retro. Tell us a bit more about it. Its design, where it was, how it actually worked in the 1970s.
The big year. Yeah, officially it was the Ohio State University Radio Observatory, but everyone called it the Big Ear. It was a truly remarkable piece of engineering located out in the quiet rural landscape of Delaware, Ohio. And unlike many modern dish telescopes, the ones that can pivot and track things across the sky,
Yeah.
the Big Ear was largely stationary. It was huge, spanning an area roughly the size of 3 football fields, just built right into the landscape. Its design was pretty unique, too. It used this massive flat reflector again, think 3 football fields, to bounce incoming radio waves off a smaller, curved parabolic reflector, which then focused them onto these receiving antennas, the feed horns.
So it didn't move to follow things?
Yeah. Nope. Because it was fixed, it relied entirely on the Earth's natural rotation to sweep its field of view across the sky. Just imagine the Earth spinning, and the telescope just patiently waits for different bits of the cosmos to drift through its fixed beam. Its particular setup also let it scan the sky in 2 distinct parallel beams at the same time.
2 beams. Why 2?
Well, it essentially let them listen to 2 slightly different points in the sky simultaneously, kind of like having 2 ears listening at once, but pointed slightly differently, constantly searching for those elusive narrowband signals. And this wasn't just some general astronomy project. The Big Ear was specifically reconfigured, dedicated to the SETI experiment. It was pioneering stuff back then, continuously searching for extraterrestrial intelligence for over 2 decades.
20 years.
Yeah. And it's really hard to overstate just how, primitive the technology was compared to what we have today. There was no digital storage like we think of it now, no gigabytes saved onto hard drives. It was all about reams and reams of paper printouts. The analog age of cosmic listening, truly.
Right. So if they weren't storing data digitally, how was all this cosmic information collected and processed, and ultimately, how was it read? The idea of reading the cosmos on paper just sounds incredibly tedious.
Oh, it was incredibly labor-intensive. Absolutely. A real testament to the dedication of those researchers. The Big Ear used this unique alphanumeric printout system. As the telescope listened, it measured the signal intensity above the background noise. It did this every 12 seconds across its 50 different frequency channels. But this intensity wasn't recorded as a number on a screen. It was translated into a single character, then printed onto this continuous roll of paper by an old-school line printer. You know the type.
Yeah, loud and clunky. So what did the characters mean?
It was ingenious in its simplicity, really. A zerba meant just background noise. 1 meant a signal just slightly stronger than the noise, and that went up to 9. But for signals even stronger than 9, the system switched to using letters of the alphabet, A through Z. Each letter represented increasing signal strength beyond what the numbers could show. So A was stronger than 9, B stronger than A, and so on, all the way up to Z, which indicated the absolute strongest possible signal the system could register.
Okay, so you're literally looking for letters jumping out from a sea of zeros and low numbers.
Exactly. Analyzing the data wasn't done by some fancy computer algorithm highlighting anomalies. It was a very manual, very human-centric task. Astronomers, often volunteers actually, spent countless hours visually scanning these huge rolls of paper, just looking for anything out of the ordinary, anything that deviated from the expected zeros and ones of cosmic static. It was a search for a pattern, a spike, a whisper, printed out 1 character at a time.
And that incredibly patient analog process brings us right to the moment of discovery itself. Can you paint a picture for us? Who was Jerry R. Emmon, and what was his routine like sifting through these endless paper scrolls?
Jerry R. Emmon. He was a truly dedicated, very methodical guy, a volunteer astronomer at Ohio State University who just devoted his time to this SETI project. His routine was exactly as we've described, poring over these vast, continuous printouts, often late into the night or early morning, day after day, week after week. It was meticulous work, often monotonous, like looking for one unique sentence in an encyclopedia where every page looks almost identical. He was just used to seeing nothing but the background hum of the universe. Long strings of zeros, ones, maybe the occasional low number. The job demanded incredible patience and a really keen eye for anything subtle, any anomaly.
Must have been hard to stay focused.
Oh, absolutely. So, picture this scene. It's the early morning of August 16th, 1977. The signal itself was actually detected just after midnight on the 15th, but he found it on the printout later. Jerry's in a quiet room, maybe a bit tired from the sheer repetitiveness of the task, scanning the latest roll of paper data, just looking for any sequence that breaks that mundane pattern. And then, bam, suddenly his eyes fall on the sequence that just screams for attention. 6EQUJ5.
6EQUJ5.
Yeah. And his initial reaction wasn't, some calculated scientific analysis. It was pure, unadulterated astonishment. This wasn't just a faint blip. It was strong, clear, an unmistakable burst of intensity that literally jumped off the page compared to everything around it.
Wow.
The sheer shock and excitement of that moment were so profound, so visceral. He grabbed a red pen, circled the sequence right there on the printout, and he scrawled a single emphatic word in the margin. Wow. Just like that. It wasn't a formal scientific note, It was a raw human exclamation of disbelief and pure elation. And that single handwritten word, born from a moment of pure scientific awe, instantly gave the signal its iconic name. It just forever underscored the immediate, powerful impact it had on the person who found it. A reminder that discovery often comes with a very human reaction.
Okay, let's dive deeper into that sequence then. 6EQUJ5. To us listening, it sounds like some kind of secret code, maybe. What exactly does it mean? What did those characters tell Jerry Eman, apart from making him say, wow?
Yeah, it does look cryptic, doesn't it? So it's actually quite straightforward once you understand the big ear's alphanumeric system. That sequence, 6EQUJ5, is a direct, almost graphical representation of the signal's intensity curve as it swept through the telescope's beam. Think of it like a perfectly formed bell curve, but plotted out with letters and numbers instead of a smooth line.
A bell curve made of carriages.
Exactly. Let's break it down. The 6 forb meant the signal first appeared at an intensity 6 times stronger than the background noise. Then, as the source moved deeper into the center of the telescope's beam, it rapidly intensified. E meant it was 14 times above background noise. Remember, A10, B11, etc., so E is 14. Then it jumped to Q, which translates to 26 times above background noise.
Getting really strong now.
Oh, yeah. And then the signal peaked spectacularly at U. U corresponds to a signal that was about 30 times stronger than the normal background noise of the cosmos.
30 times? That's huge.
It's incredibly powerful. This wasn't a faint whisper, it was a clear shout. After hitting that peak at U, the signal then began its symmetrical decline. It dropped back down to J, which is 19 times above noise, and finally down to 5 times above noise, as the source moved out of the beam. So this wasn't just some faint random blip. It was a powerful, coherent burst that stood out dramatically.
And the shape, that rise and fall, was important too.
Critically important, because this specific pattern, the gradual rise to a peak, and then a perfectly symmetrical gradual decline, matched exactly the expected signature. It matched what you'd expect for a fixed point source entering and then exiting the telescope's stationary beam as the Earth rotated. It had the perfect profile for an astronomical source, something far away and fixed in space.
That is absolutely fascinating. So the telescope itself had this built-in time limit for any fixed signal, an incredible design constraint that's now a key part of the mystery. The signal lasted exactly 72 seconds. Why that precise duration? Was the message exactly 72 seconds long, or was something else dictating the timing?
That 72-second duration is not just crucial. It's arguably one of the most compelling pieces of evidence supporting the idea it was extraterrestrial, or at least extrasolar system. Precisely because it was dictated by the telescope itself, not necessarily by the source turning on and off. Remember, the Big Ear telescope was stationary. You couldn't physically track an object across the sky. So as the Earth rotated, any fixed point source out there in the distant cosmos, like a star, a planet, or, yes, maybe an alien transmitter, would enter the telescope's fixed field of view. It would rise in intensity as it passed through the center of the beam, and then it would gradually fade as it moved out of the beam's path.
Just because the Earth turned.
Exactly. And for the Big Ear's specific design, its specific orientation and beam width, that entire transit time, from the moment a fixed source first entered the beam to the moment it completely left it, was calculated to be exactly 72 seconds.
Wow, exactly 72 seconds.
Exactly. The fact that the signal lasted for precisely 72 seconds was incredibly significant. It perfectly mimicked what you'd expect from a distant, fixed point in space. It behaved just as a celestial object should. This strongly suggested an astronomical origin, rather than some fleeting local interference or something moving erratically on Earth. It appeared, rose to maximum, and faded as the source simply moved out of the beam's path due to Earth's rotation.
But that raises a huge question, doesn't it?
It does, an almost agonizing question, really. If it was a real signal, a true communication, could we have heard more? Could the message have continued if only the telescope had been able to follow it? We simply don't know. The very nature of the instrument being fixed meant that as soon as Earth's rotation carried the source out of view, that was it, signal gone. The telescope couldn't pivot to chase it. It's just a profound moment of what if in the history of science.
So let's pull back and look at the bigger picture here. Why did this particular signal stand out so dramatically from all the other noise, all the static that astronomers were listening to day in, day out? What made it so fundamentally different from everything else they'd ever recorded?
Well, there are several really compelling reasons why the signal wasn't just another blip, why it continues to command scientific attention. First and foremost, as we've touched on, was its frequency. It was detected at 1420.4556 millihertz. Now that is incredibly, almost perfectly close to the universal hydrogen line at 1420.4058 megahertz.
The cosmic hailing frequency.
Exactly. This near-perfect alignment made the signal intensely compelling. Why? Because it precisely matched SETI's long-held hypothesis about how advanced civilizations might choose to broadcast a beacon. It felt less like a random emission and more like a deliberate, focused communication, a purposeful choice of frequency, suggesting an attempt at universal understanding. It's like someone choosing to call you on the exact phone number you'd secretly hope they might use out of billions of possibilities. It felt targeted.
Okay, so the frequency was spot on. What else?
Secondly, its signal profile was just pristine. That smooth rise and fall we talked about, the 6E-UJ5 pattern, perfectly matched the expected curve for a fixed-point source as the Earth's rotation swept the telescope beam over it. This characteristic was absolutely vital for ruling out the vast majority of typical terrestrial interference. Earth-based signals, things like airplanes, satellites, TV broadcasts, even faulty equipment, they usually have erratic, fluctuating, or very different time signatures that wouldn't typically show that precise, symmetrical 72-second bell curve shape. Terrestrial interference often appears as bursts that jump on and off quickly, or maybe sweep through the beam much faster or slower. Signal was clean, unwavering, and behaved exactly as an object millions of miles away, fixed in space, should.
And you mentioned something about this frequency being protected.
Yes, and that's crucial too. The frequency band around 1420 millihertz is actually a protected band. This isn't just a casual guideline, it's an international agreement. Radio astronomers globally agreed to keep this specific channel clear of human-made transmissions. Imagine the effort silencing our own noise on that particular frequency, precisely so we could hear a whisper from another world. This international protection significantly reduces the likelihood of Earth-based interference accidentally mimicking such a unique signal in that specific band.
So we have this perfect storm, really. The right frequency, the perfect profile in a protected band. It sounds almost too good to be true, which brings us to the most frustrating part.
Yeah.
Silence. One signal, and then nothing. That must be the most agonizing aspect of this mystery.
Absolutely.
Yeah.
That is precisely the most frustrating and, profoundly puzzling aspect of the signal.
Wow.
It was only detected once. Since that incredible night in 1977, countless follow-up searches have been conducted. Just countless. The big ear itself kept operating for years, constantly repointing its fixed gaze toward that same region of the sky, just hoping for a repeat performance. And when it was eventually decommissioned, other, much more powerful observatories around the world picked up the torch.
Like Arecibo, the VLA.
Exactly. Astronomers using instruments like the Arecibo Observatory before its collapse, sadly, the Very Large Array in New Mexico, dedicated SETI projects like those run by the SETI Institute. They've all pointed their cutting-edge telescopes at the precise sky location where the signal originated, hoping to hear it again. They've listened for hours, days, weeks, across various frequencies surrounding the hydrogen line. And every single time, nothing, utter silence.
Just nothing.
It's this lack of repetition that's the primary reason the signal remains unconfirmed and unexplained, despite all its otherwise incredibly compelling characteristics. It's the ultimate what if. If it really was from another civilization, why just once? Was it a fleeting hello? A broadcast that happened to sweep across our tiny corner of the galaxy momentarily? Or are we, even with our best tech, just not patient enough, or maybe just not lucky enough to catch it again? This frustration, it fuels both ongoing scientific dedication and, yeah, maybe a touch of cosmic melancholy.
Okay, let's put on our detective hats. Let's play cosmic detective. Could it have just been something natural, something out there in space that just happened to align perfectly with our equipment and our expectations? What are the usual suspects for cosmic radio signals, and why were they ultimately ruled out for the Gauss signal?
Right, that's always the first logical step in any scientific mystery. Explore all the natural explanations first. The first natural sources that often come to mind for powerful radio emissions are things like pulsars or quasars. These are truly powerful cosmic engines. Pulsars are these rapidly spinning neutron stars, flashing beams of radiation like a cosmic lighthouse. And quasars are incredibly bright centers of distant galaxies, powered by supermassive black holes. They are definitely strong radio emitters.
So could it have been one of those?
Well, they were very quickly dismissed as potential sources for the WOW signal. The reason is fundamental. Pulsars and quasars produce broad spectrum emissions. Their energy is spread out across a wide range of frequencies. Remember our analogy? They produce the noisy waterfall, not the single flute note, that narrow bandwidth of the signal. That's a hallmark of artificiality, or at least something highly unusual, not these known natural phenomena.
Okay, so pulsars and quasars are out. What about other natural ideas? I remember hearing something about comets.
Ah, yes, the comet hypothesis. That gained some traction for a while. It was proposed by Antonio Paris back in 2015. He suggested that hydrogen clouds surrounding certain comets, which might have been passing through the Big Ear's beam at the time, could have been the source. Specifically, he pointed to two comets, 266P Christensen and 335P Gibbs. They weren't actually discovered in 1977, but their orbits suggested they might have been in the general vicinity around that time. His idea was that the neutral hydrogen in the comet's comas, their atmospheres, might have emitted at or near the hydrogen line frequency as they passed through the telescope's beam.
An interesting idea. Did it hold up?
Well, it was an interesting attempt to find a natural explanation, but it was largely criticized by the broader astronomical community and ultimately doesn't really hold water under closer scrutiny. There are several key problems. First, the signal's immense strength. Remember, 30 times background noise and its incredibly narrow bandwidth just don't match known comet emissions. Comets, yeah, they have hydrogen, but they don't emit with that kind of focused intensity or precision. Their emissions are typically much fainter and much broader in spectrum.
Okay, so strength and bandwidth don't match. Anything else?
Yes. Second, comets move relatively slowly, but they move across the sky. Their diffuse emissions wouldn't typically fit that precise, fixed 72-second sweep profile of the Big Ear in the exact perfectly symmetrical way the signal did. The signal's profile screamed fixed distant source, not nearby moving diffuse cloud. And perhaps the most crucial point, when astronomers double-checked the math, the predicted positions of those specific comets, they weren't actually in the precise spot in the sky covered by the Big Ear's beam at the exact time the signal was detected.
Ah, so they weren't even there.
Not exactly in the beam, no. And subsequent observations of these comets when they were observable didn't show any emissions remotely resembling the WOW signal. So while it was a good thought, an attempt at a non-alien explanation, the comet hypothesis largely failed to explain the unique, singular characteristics of the signal. The mystery remained.
So if it wasn't a known natural cosmic event, what about something closer to home? Could it have been some kind of man-made interference? A satellite whizzing by, an airplane, maybe some kind of weird rogue broadcast from Earth that just happened to mimic that perfect profile?
That's always a huge consideration in SETI. Terrestrial interference or RFI radio frequency interference is the bane of radio astronomers' existence. We're just swimming in a sea of human-generated radio signals, cell phones, Wi-Fi, TV, radar, satellites, aircraft, even leaky microwave ovens. Honestly, most anomalous signals detected by radio telescopes do turn out to be RFI. It's the default assumption you have to rule out first.
So why is it largely discounted for what?
For several compelling reasons we've touched on. First, that protected frequency band around 1420 megahertz. International agreements reserve it for radio astronomy, significantly reducing the chance of accidental interference from common sources.
No.
It's supposed to be a quiet zone.
Supposed to be.
Right, things can still happen, but it helps. More importantly, though, is the signal's characteristics. That pristine beam shape and the precise 72-second duration just don't fit typical interference patterns. Airplanes or satellites moving through the beam usually produce much quicker, more erratic signals. Their signatures often look like spikes, or they might drift in frequency due to the Doppler effect as they move. The WOW Signal was stable in frequency, clean, and had that perfect rise and fall profile consistent with the Earth's rotation, carrying a fixed distance source through the beam. It just behaved too much like something truly astronomical, not like the usual terrestrial phantoms astronomers are used to filtering out. It makes RFI a very unlikely explanation.
Which leaves the elephant in the room. Or maybe the alien in the room. The extraterrestrial transmission. Even with zero confirmation, no repeat signal. Why does this possibility persist so strongly for the wow signal after nearly 50 years of silence?
It persists, I think, precisely because of how incredibly well the signal's unique characteristics align with exactly what SETI scientists had predicted they might find,
Yeah.
even if it was only once. The narrowband nature, the immense strength, 30 times background, the precise frequency right near the universal hydrogen line, and that perfect 72-second profile matching the telescope's sweep. These are all incredibly strong indicators that if it was artificial, it was likely a deliberate and technologically advanced transmission. It just checked almost every single box on the SETI wish list.
It fit the profile perfectly.
Astonishingly well. So many researchers, while always adhering to that critical principle of extraordinary claims require extraordinary evidence, which means a single, unrepeated detection isn't enough for confirmation. They still seriously consider the possibility it was a broadcast from another civilization. Think about the possibilities. It could have been a one-time, highly directional transmission, like a powerful, focused beam from a distant source that just happened to sweep across Earth and the Big Year for that brief 72-second window.
A cosmic lighthouse beam hitting us for a moment.
Exactly. Or it could be a repeating signal, but one that's incredibly rare or sporadic. Maybe it only broadcasts for a short period every few decades or centuries or millennia. We might simply not have been looking at the right place at the right time with the right sensitivity to catch it again. The universe is vast. Timescales are immense. This enduring, tantalizing hypothesis is what continues to drive follow-up observations and fuels the hope that one day, maybe, we might hear it, or something very much like it again. It remains the most compelling candidate for an extraterrestrial signal ever detected.
Okay, let's indulge in some informed speculation then. If the wow signal really was a message, an intentional communication, what can we actually infer about the beings who might have sent it? What does this single string of characters, 6EQUJ5, potentially tell us about their technology, their intentions, maybe even their understanding of the cosmos?
That's a fantastic thought experiment, and it lets us speculate based on the signal's properties. Assuming it was alien, we can infer quite a bit, actually.
Yeah.
Firstly, the narrowband nature points to extremely advanced radio technology. It suggests a civilization capable of incredibly precise frequency control. Focusing their energy into such a tight band isn't easy. It speaks to sophisticated engineering, probably aimed at maximizing transmission efficiency over vast distances. This isn't primitive stuff.
So they're likely technologically way ahead of where we were in 1977 or even now.
Almost certainly. Secondly, the sheer power, 30 times background noise, implies a remarkably strong transmitter. We're not talking about a faint whisper barely picked up. This was a shout across the cosmos that cut through the natural static, loud and clear. Generating that kind of power and aiming it effectively over interstellar distances would require significant energy resources and, again, incredibly advanced engineering. It doesn't feel like accidental leakage from, say, their equivalent of TV broadcasts.
More like a dedicated beacon.
Possibly. And finally, their choice of frequency, right near the hydrogen line, suggests a potentially profound shared scientific understanding. It implies that these beings, wherever or whatever they are, understand fundamental physics, specifically the properties of hydrogen and radio waves, just as we do. This alignment points towards either a deliberate attempt at universal communication using that cosmic handshake frequency, or perhaps even just an accidental leakage from their advanced systems that happen to operate near that universally significant frequency. Either way, it speaks volumes about their scientific and technological maturity. They could be millions, maybe billions of years ahead.
So if it was intentional, was it maybe just a fleeting hello, a one-time burst? Or could it have been part of something much bigger that we just happened to catch a tiny fraction of?
That's one of the core what-if scenarios, isn't it? The nature of that single detection really shapes how we think about it. Let's explore some possibilities. Could it have been accidental? Maybe just stray signal leakage. Imagine their internal communications, maybe energy transmission systems, or even weird propulsion byproducts, briefly beaming our way just by chance as their planet rotated or their antenna swept past, like catching a snippet of someone else's conversation on a crossed line, but across light years. It implies it wasn't for us, we just happened to overhear.
Serendipity on a cosmic scale.
Exactly. Or Was it intentional? A purposeful broadcast, maybe even targeted? If so, the big question remains, why only once? Could it have been a burst transmission? A very short, powerful pulse designed to convey a lot of data quickly, perhaps part of a much larger stream sent in packets. We might have only caught one burst. Or maybe it was a signal deliberately testing for a response, a kind of cosmic ping, hello, anyone out there, that they only send out periodically, maybe every few decades or centuries. And we just happened to be listening during that one transmission window in 1977. The silence, since could mean they moved on, didn't get a reply, or their transmission cycle is just incredibly long. The possibilities really do make your head spin.
It really does. And it raises this other important question. What if the cosmos is constantly chattering, a universe alive with signals, maybe even conversations, and we're just not tuned in at the right time? It feels like trying to catch a specific radio station that only broadcasts for 72 seconds once in a lifetime while randomly spinning the dial.
That's a perfect analogy. Wow. Signal truly highlights the sheer, almost incomprehensible scales of space and time involved, and the incredible challenge of SETI. Even if a civilization is regularly broadcasting, perhaps even aiming signals our way occasionally, the chances of one of our specific telescopes being pointed in exactly the right direction, tuned to precisely the right frequency at the exact moment a signal arrives, those chances are incredibly slim. It's like trying to catch a specific marked raindrop during a brief downpour, using only a thimble while blindfolded.
Not great odds.
Not great odds at all. We might be listening intently, but we're only sampling tiny, tiny fractions of the cosmic radio dial for very limited periods across unimaginably vast distances. Wow. Signal is a stark, almost poetic reminder of this needle-in-a-haystack problem. It forces us to ask, is the silence we usually hear a sign of cosmic emptiness, or just the limit of our own perception? It really underscores the need for constant, wide-ranging monitoring, bigger telescopes, more sophisticated listening techniques that can cover more sky, more frequencies, all the time. It makes you wonder, doesn't it, how many other potential wow signals might have washed past us completely undetected simply because we weren't listening then or didn't have the tech to notice. It's sobering, but it also drives innovation.
Absolutely. So after all this speculation about its nature and meaning, let's talk location. Where in the vast universe did this signal actually seem to come from? Did we get a cosmic address, some specific spot in the sky we could theoretically point other telescopes towards for follow-up?
We did get a celestial address, yes. Though, unfortunately not with pinpoint accuracy, mainly due to the technology of the big ear itself. The signal appeared to originate from the direction of the constellation Sagittarius, specifically near a star group called the Chi-Sagittarii group. Now, Sagittarius is a fascinating part of our sky to consider because it lies in the direction of the Milky Way's dense galactic center. It's just teeming with billions and billions of stars. So when you look up at Sagittarius in the night sky, if you can find it, you can kind of visualize that distant, crowded part of our galaxy as the potential source region for this incredible, mysterious signal. It gives it a place, at least.
But I remember you mentioned something earlier about uncertainty, something about the big ear having two beams. How did that affect pinpointing the source?
That's absolutely correct. And it's another one of those frustrating technological limitations from the 70s that adds another layer to the mystery. The Big Ear telescope, as we discussed, scanned the sky using two parallel beams simultaneously. Think of it like having two adjacent spotlights scanning the sky, slightly offset from each other. The wow signal was detected strongly in only one of those two beams. The other beam, listening to a slightly different patch of sky at the same time, heard nothing unusual.
Ah, so it could have come from either beam's patch of sky?
Exactly. Because the signal only showed up in one beam, we know it came from the area of sky covered by that beam. But we don't know for sure if it was in the first beam or the second beam as they swept across. This means there are actually two possible sets of coordinates in the sky, two slightly different locations, where the source could have been. This ambiguity significantly complicates follow-up searches. Instead of astronomers being able to point their modern powerful telescopes at one single precise spot with full confidence, they have to essentially hedge their bets, splitting precious observation time between two potential slightly separated source regions. It's like knowing your lost keys are in one of two adjacent rooms, but not knowing which one. It just highlights the level of precision needed in SETI, and how even small ambiguities can create challenges decades later.
Okay, so we've covered the context, the discovery, the signal's unique properties, the potential explanations, natural, man-made, extraterrestrial, and the lingering questions. Now, for you listening, you've heard all the facts, the theories, the speculation, the enduring mystery, the wow signal. We've explored the science, the implications, the frustration of the silence. So, what resonates most with you? After hearing all this, which explanation for the wow signal do you find most convincing? Is it natural, man-made, or something truly, well, alien?
And we really encourage you to think critically here. Question the assumptions, consider all the viewpoints. There's no single easy confirmed answer, and that's honestly part of the enduring allure of the wow signal. It forces us to confront the unknown and really weigh the evidence. Does the sheer improbability of its characteristics, the narrow band, the strength, the profile, the frequency, push you towards an extraterrestrial source, even without repetition? Or does that scientific principle, extraordinary claims require extraordinary evidence, make you lean towards a more mundane explanation, even if we haven't found it yet? It's a genuinely fascinating puzzle to ponder.
And let's take it one step further. If this signal was a call, a deliberate hello from across the cosmic ocean, what was your first contact scenario look like? How do you imagine humanity would react? Would there be panic? Unity? Would we immediately try to shout back? What would you personally want us to do if that wow moment suddenly became a sustained conversation?
It's a question that goes way beyond just science, doesn't it? It touches on sociology, philosophy, our deepest hopes, and maybe even our fears about humanity's place in the universe. Would we even be ready for such a profound encounter? Could we even decipher a message? Or would it be so utterly alien as to be incomprehensible? Would it be a friendly greeting, a warning, or just an announcement? We are here. These are the huge questions sparked by just 72 seconds of anomalous data. It reminds us that the search for intelligence out there is also, in a way, a search for understanding ourselves and our readiness for what might be. It really tests our collective imagination.
Absolutely. And for a little bit of cosmic trivia before we start to wrap up this deep dive, did you know that the hydrogen line frequency, that 1420 megahertz, is considered such a universal meeting point for reasons even beyond just hydrogen being common?
Yes, that's right. It's absolutely fundamental, and it's more than just a chemical signature. That specific frequency has another advantage. It can penetrate the dust and gas clouds that fill interstellar space relatively easily,
Yeah.
much better than, say, visible light or higher radio frequencies. So a signal broadcast on or near the hydrogen line could travel across vast interstellar distances with minimal loss or scattering.
So it's not just universally known, it's also a really good frequency for long-distance calls.
Exactly. It's kind of the perfect combination. Not only is it linked to the most abundant element, making it universally recognizable, but it's also physically ideal for long-distance interstellar transmission. It's a common denominator that any advanced civilization understanding basic physics might gravitate towards for broadcasting, both for its universal significance and its practical advantages. If we try to connect all these threads, the wow signal really highlights both the immense promise and, let's be honest, the profound frustration inherent in the search for extraterrestrial intelligence. It shows how even one brief, unrepeatable anomaly can fuel decades of dedicated science, rigorous follow-up attempts, and this enduring public fascination. It stands as both a beacon of hope and a persistent puzzle that just keeps us listening, keeps us searching, reminding us of the incredible possibilities that might lie just beyond our current perception.
And so, the mystery absolutely endures. Despite all our modern technology, these vast radio observatories, sophisticated AI scanning the skies constantly, powerful new instruments coming online, we've never heard anything quite like it again. Just the big ear, Jerry Amen, a single circle on a piece of paper, and that one, perfect word, wow. Time. Was that, wow, signal our only call from the cosmos, or was it just the very first one we happened to notice?
The deep dive continues. In the silence between the stars,